IB Standard Level Maths Calculus. So we're going to have a look at a past paper question involving differentiation and integration. This is a non-calculator paper and it's worth question and it's worth 14 marks. So the following diagram shows a graph of the function f. There is a local minimum point at A, and if you have a look at the curve here, you can see A. This is a cubic graph by the shape. The derivative of f is given by f dash of x equals 3x squared minus 8x minus 3. Okay, so this is worth 40 marks altogether and it's over 3 parts. So the first part, A. Find the x coordinate of A. Okay, so it's really important to notice from the question that we're looking at a minimum point. So any kind of stationary point, minimum or maximum, has a gradient of 0. So the gradient of turning point is 0. So we take our 3x squared minus 8x minus 3 and make that equal to 0. We need to factorise into brackets. We know that we need a plus and a minus because we have a minus here. We know that it has to be a 3 and a 1 next to the x and 3 and 1 on the end because 3 and 3 are prime numbers. So we just need to work out which the combination to give this the minus 8x. So 3x plus 1 multiplied by x minus 3 will give us that because the 3x times minus 3 gives you minus 9x, and then plus 1x will give you your minus 8x. So either of the brackets is equal to 0, so either 3x plus 1 is equal to 0 or x minus 3 is equal to 0. So for this one, x is equal to minus a third, or x is equal to 3. So the minus a third will be this point here on B. Let me just show you that. So this is your minus a third here. That's that one. And then your A is here on your 3. And that's worth 5 marks. You get a mark for saying it's equal to 0, and then the rest of your marks are for finding those points. Okay, so part B. The y-intercept of the graph is at 0, 6. Find expression for f of x. Okay, so we need to find the original equation of the curve. So to do that, we need to integrate. So if f dash of x is equal to 3x squared minus 8x minus 3, then f of x will be equal to x cubed minus 4x squared minus 3x. And then the most important thing here is to remember the plus c, because without that, the rest of the question won't work. So now we need to use the coordinates that we've been given. So we substitute in the 6 into y and the 0 into x. So that gives us 6 equals 0 cubed minus 4 lots of 0 squared minus 3 lots of 0 plus c. That's lots of zeros. So c is 6. And that gives us a final equation of f of x equals x cubed minus 4x squared minus 3x plus 6. Really important when you're integrating that you remember the plus c and that you always use all the information from the question. So if you'd have got to the point where you'd forgotten the plus c, when you go back and reread the question, obviously they've given you the 0, 6 for a reason, so have a think about what that might have been for. Okay, part C is actually quite a challenging question. It just takes a little bit of thought. So the graph of function g, as in a new graph, is obtained by reflecting the graph of f in the y-axis, followed by a translation of m and n. This is a transformation question. So we need to find the x-coordinate of the local minimum of the point of the graph g. Okay, so let's try and do this step by step. The first thing it says is the graph of the function is obtained by reflecting the graph of f in the y-axis. So all I've done here is taken the graph and reverse it. You can see that my x and y are backwards now, just so you can see the shape of the graph. So A is still the minimum, but it's now going to be an inflection of y. So A is now the local minimum point, and the x-coordinate will be minus 3 because A was originally 3. Okay, that's our first mark. Now we need to follow this by a translation of mn. Well, m is the horizontal translation and n is the vertical part of the translation. So we only need to be concerned about the horizontal translation. So it started at minus 3 and then we've added on m. Then the new value of x will be minus 3 plus m.